I'm Dr. Pariser, and I'd like to talk to you about the power in an electromagnetic wave. Actually, when you sit on the beach or you lie on the beach, you get a sunburn. So why do you get a sunburn? Because the sun is shining power on you. And if you're in the sun too long, you get a sunburn and it's very painful. I'd like to tell you that power in an electromagnetic wave is represented by Poynting's vector. So Poynting's vector is E cross B over mu 0. Okay, E is the electric field, B is the magnetic field, and mu 0 is the magnetic constant. All right, so E has the units of newtons per coulomb, and B has the units of Newton seconds per coulomb meter. Now, what about mu 0? What about mu 0? From Ampere's law, B dot ds equals mu 0 I. And so this is Newton seconds per coulomb meter times meters. And that's mu 0 times coulombs per second. And so what we have is Newton seconds squared per coulomb squared is mu 0. Okay? Now what is this? Poynting's vector is going to be newtons per coulomb times Newton seconds per coulomb meter, and divided by Newton seconds squared coulomb squared. All right, what happens here? Going across, I have Newton squared seconds over coulomb squared meters, divided by Newton seconds squared over coulomb squared. All right, so how do you do this? How do you do this? Well, the game plan when you have messy fractions is to multiply by a fraction that will turn the numerator into 1. So if I multiply by Newton seconds squared per coulomb squared, I have to do the same for the top and bottom. Coulomb squared, Newton seconds squared. What happens on the bottom? This goes out, this goes out, that goes out. What happens on the top? Coulomb squared goes out, okay, Newton goes out, and one of these seconds goes out. So what does Poynting's vector come out to be? Comes out to be Newton over meters seconds. Now, what happens if I multiply a fraction by 1? Do I change its value? 5 times 1 is 5. 123 times 1 is 123. So if I multiply this by a fraction that's equal to 1, it won't change its value. The fraction I'm going to multiply by is meters over meters. And what does that do? On top, I have Newton meter. On the bottom, I have meter squared seconds. What is a Newton meter? It's a joule. And a joule per second, and this is meters squared. And what is a joule per second? A watt per meter squared. So Poynting's vector has the units of watts per meter squared. And actually, if this is the sun and this is the earth, near the surface of the earth, it's 1,350 watts per meter squared. Now, before I conclude, I'd like to say that when you're lying on the beach and none of you would take None of you would turn on the light bulb and put your hand on the light bulb. But when you're lying on the beach, there's 1,350 watts per meter squared shining on you. Now your surface area is not a square meter, but let's say it's a quarter of a square meter. That's pretty darn hot. So just realize the next time you're on the beach that the sunlight is coming to you as an electromagnetic wave carrying power. Thank you.